Okay, so in this video I'm going to go over problem 17 from chapter 3. So they gave us, the problem, formulated the problem in the book. So all I want to do here is, put it into Excel, solve it, and then answer the questions. Okay, so again, we're going to maximize profit. We have two types of roll bars, the DRB and the DRW. So here my parameters are 200, 280. Insert placeholders, objective function, same as always. There, and they, oh, whoa, that's bad. There and there. Okay, my constraints for steel, I have 20 and 25 for manufacturing. Oops. 40 and 100. These are manufacturing minutes, assembly minutes. That's 60 and 40. All of these are less than or equal to constraints. And my constraints are 40,000, 120, 96. Okay, and then my constraints based on my choice variables. All right, so here is the problem in Excel. So now we just need to solve this guy. So data, solver. Okay, my objective function, I want to maximize that by changing these two cells subject to these three constraints being less than or equal to these three constraints. Non-negativity, simplex LP, solve, get your reports, hit OK, and voila. So we want to produce 1,000 DRB roll bars, 800 DRW roll bars, and by doing that we'll have a profit of $424,000. Okay, so that was A. So another supplier offered to provide Deegan Industries with an additional 500 pounds of steel alloy at $2 per pound. Should Deegan purchase the additional pounds of steel alloy? All right, so go to the sensitivity report. So we're looking at steel. So the shadow price tells me that, for every pound of steel, my profit is going to go up. For every additional pound of steel I get, profit will go up by $8.80. Since this company is going to sell it to me for $2 per pound, I would say yes. And then they want to sell me 500 pounds. Well, I can go up to 909 pounds and this shadow price will still be valid. So yes, Deegan should buy 500 additional pounds of steel at $2 per pound, and notice that it will make an additional, because I have to pay the extra $2 per pound, I'm going to make an additional $6.80 on those 500,000 pounds of steel that I purchased. All right, so there's B. C. Deegan is considering using overtime to increase the available assembly time. What would you advise? So, assembly time. I would advise no, right? The idea here is the shadow price is zero, so adding more assembly time is not going to help me. And you can also see that here, because the shadow price is zero, I have slack in my assembly time, and I actually have 4,000 minutes of slack. So I don't need any more assembly time minutes. D, because of increased competition, Deegan is considering reducing the price of model DRB such that the new contribution to profit is $175 per unit. Will this change in price affect the optimal solution? All right, so I got to go back to sensitivity. So DRB, yeah, DRB. Okay, they want to drop this down to 175. Notice that I can decrease this by $88. So 200 minus the 88. So I can drop the profit contribution of the DRB to $112, and my production plan will not change. Of course, my optimal profit is going to fall, but my production plan will not change. So yes, can they do it? Definitely. They're still going to produce, these many units, but profit will decline. Okay. If the available manufacturing time is increased by 500 hours, will the dual value for the manufacturing time constraint change? Manufacturing. Okay, so I can go to, now, 500 hours, these are in minutes. So 500 hours, I have 60 minutes in an hour. So basically, can I increase manufacturing by 3,000 minutes? Yes. So if I increase manufacturing minutes by 30,000, this shadow price or dual value will still remain valid. So for every minute I increase manufacturing, my profit will increase by 60 cents. All right, well, there you go. There is, what I say, problem 17 in chapter 3.